Let's look at this example. We want to find the polynomial p of x with zeros of 1 plus 2i and 2 that has a multiplicity of 2. We also have the condition that p of negative 1 equals 36. So the polynomial function is going to have some multiplier out front, a, that we don't know what it is, but we'll be able to determine given that condition. Let's write down the factors that come from the zeros that are given. So the 0 of 2 will come from x minus 2. Since there is multiplicity of 2, that means that that factor is squared. So we could write it as x minus 2 squared. Then we have a 0 of 1 plus 2i, a complex 0. So that's going to be 1 minus, in parentheses, 1 plus 2i. Since it is a complex 0, that means that it comes in a conjugate pair. So it's going to force it to have another 0 of its complex conjugate, which is 1 minus 2i. Now let's use the condition to determine what a is. So we are going to replace x with negative 1. So we'll have this unknown a times negative 1 minus 2 squared times negative 1 minus 1 plus 2i times negative 1 minus 1 plus minus 2i. All right, and we're told that that is equal to 36. So we've got 36 equal to, we don't know the a, but we can do the arithmetic on these other pieces. All right, this negative 1 minus 2, we get negative 3 squared, so that's going to be a times 9. Okay, now let's multiply these other things together. We'll start off by negative 1 times negative 1, so that is going to be a positive 1. Then we do the outside terms, so negative 1 times this complex number, and that is going to be negative 1 times a negative times a 1, so that's going to end up being plus 1. And then we have negative 1 times a negative 2i. So 3 negatives, so that ends up being minus 2i. All right, now let's multiply together the inside terms here. So we've got negative 1 times a negative times a 1, so that's a plus 1. And then we've got negative 1 times a negative times a 2i, so that ends up being plus 2i. And now let's multiply the complex conjugates together. Now, whenever we multiply complex conjugates together, you square the real part and add it to the square of the imaginary part. So that is going to be, the square of the real part is 1, so that's a plus 1. And then the square of the imaginary part, that's the square of the negative 2, or the 2. And so square that and we get 4. Okay, now let's simplify what we have. So we have the 36 equals a times 9. Now let's look at what we have in the parentheses over here. The 2i and the negative 2i cancel each other out, and then if we add everything else together, we have 8. So we end up with 72a equals 36. So a is equal to 36 over 72, which simplifies to 1/2. Okay, so that gives us what a is. Now we want to write down what the polynomial function is. So it's going to be p of x equal to a times x minus 2 squared times x minus 1 minus 2i times x minus 1 plus 2i. Now we want to multiply this out so it's in our sort of general polynomial form. This looks really messy, but this is going to simplify out pretty nicely. Let's leave the 1/2 out in front. Let's multiply the x minus 2 times x minus 2. That's going to be x squared minus 4x plus 4. Okay. Now let's multiply the other two together. So we'll start off by first times first, so that we get an x squared. And then we will multiply the outers together. So x times the negative 1 plus 2i. So if we multiply that all out, we're going to end up with a negative x and a negative x times 2i. Okay, next term, the inners. So if we multiply those together, we get a negative x, and it's going to end up being a plus x times 2i. And finally, the last terms. So we're multiplying complex conjugate times itself. So when we do that, we end up with 1 squared plus 2 squared, so that's 5. And it's a negative times a negative, so that's going to be a plus 5. Now we see that the terms with the x and the i's are going to cancel each other out. So we end up with 1/2 out in front, x squared minus 4x plus 4 times this quadratic, x squared, combine those x's, we get minus 2x plus 5. All right, now we just need to multiply together those two quadratics. We're almost there. 1/2 out in front, and let's just go through x times x squared, we get x to the 4th. X times negative 2x, we get minus 2x cubed. X squared times 5, we get plus 5x squared. Okay, now we're going to multiply everything by negative 4x. So negative 4x times x squared, we get negative 4x cubed. Negative 4x times negative 2x, we get plus 8x squared. Negative 4x times 5, we get minus 20x. Now multiply everything by 4. So we get plus 4x squared minus 8x plus 20. And let's combine like terms. So we have an x to the 4th. All right, we got that one. Our x to the thirds, we've got negative 2 and a negative 4, so minus 6x cubed. So we got those. X squareds, we've got 5, 4, and 8, so adding those together, you get 17x squared. So we got the x squareds. The x terms, we have a minus 8 and a minus 20, so minus 28x, and then finally plus 20. Last thing, multiply that 1/2 through. So 1/2 x to the 4th minus 3x cubed plus 17 halves x squared minus 14x plus 10. And there's our polynomial with the given zeros, the given condition. It ends up being a 4th degree polynomial.